Two cheeseburgers and one small order of fries contain a total of 1,210 calories. Three cheeseburgers and two small orders of fries contain a total of 1,990 calories. Find the caloric content of each item. In our first sentence, we are told that two cheeseburgers and a small order of fries has 1,210 calories. And then we're told three cheeseburgers and two small order of fries have 1,990 calories. That gives us a system of equations with two variables, one for cheeseburgers, one for a small order of fries. Um, when you look at this system, this letter Y, that's probably the easiest one to isolate. So in step one, and I'm going to use substitution instead of elimination, I'm going to isolate that y. Subtracting two x's from both sides, that gives us y equals negative 2x plus 1210. Now, I'm going to go to the other equation and replace y with a negative 2x plus 1210. Take your second equation, swap out your y, distribute 2, that's 3x, so then we have negative 4x plus 2420. Combine like terms, that's a negative x plus 2420 equals 1990. Subtracting 2420 from both sides gives us negative 430. These two negatives will cancel, so x equals 430. That's calories per cheeseburger. Now, taking this back up to step one, replacing x with 430, we can now find the caloric intake of the small order of fries. Multiply by negative 2, add 1210, we get 350 calories for a small order of fries. The demand and supply equations for a laptop computer are given. P is the price per unit in dollars, and X is the number of units. Find the equilibrium the equilibrium point for this market. Okay. So since both of these are price and unit driven, we can set each one equal to one another because P is equal to both of these. Since P equals P, these other sides have to be equal as well. Set them equal. In class, you guys told me to add 0.4x to both sides first, and then take off 430. So that gets us down to 70 equals 0.5x. Divide by 0.5, we have x equals 140 units. Pick either equation, replace your x with a 140. You guys asked me to use the bottom one, so I did. P equals 430 plus 0.1 times x, but we know x is 140. Multiply, add to 430, and price is $444 when 140 units are involved. So that's our equilibrium point, 140 to 444. A total of $20,000 is invested in two corporate bonds that pay 3.5% and 5% simple interest. The investor wants an annual interest income of $820 from the investments. What amount should be invested in the 3.5% bond? Well, we have two different percentage payouts. I'm going to let X represent the amount of money in the 3.5% bond and Y be the money in the 5% bond. There's 20,000 total investment, so X plus Y has to equal 20,000. So that's one equation. X plus Y equals 20,000. And then when it comes to the interest, 3.5%, remember to divide by 100, so 0.035X plus 0.05y, they want this to be $820 for the interest payout. This is our system, these two equations here. I'm going to use substitution, take the top equation, solving for y, that's 20,000 minus x. Now go to the other equation, replace y with 20,000 minus x, 0.035x, distribute, that's 1,000 minus 0.05x. All this is still equal to 820. That's the interest payout that the investor wants. Combine like terms, 0.035x minus 0.05x. That's negative 0.015x plus 1,000, still equal to 820. Subtract 1,000 from both sides, you get a negative 180. These two negatives are going to cancel. 180 divided by 0.015 gives us x equals 12,000. Since there's 20,000 involved, $20,000 total investment, and we've just now come up with 12,000. If we had to come up with the other amount, it would be 8,000, because 12,000 and 8,000 give us the 20,000 total. But this problem just wanted to know how much would be in the 3.5% bond, and that was what we assigned to X, and we just solved for X. So $12,000 is invested in the 3.5% bond. If this problem had asked about the 5% bond, then we would just tell them 8,000